Hello everyone, my name is Nicoya, and this is the Boss RPS-10. This is the pitch shifter delay, not to be confused with the sampler delay, the RSD-10, which we repaired on a previous video. I still don't have the correct knob for that, but I do have another RSD-10, which I accidentally bought. So I guess I do have the right knobs. Anyway, that's not the subject of this video. This video is about the RPS-10. So we can power this thing on. And if I turn up the volume real loud, we can kind of hear something, but not really. And if I hold on to the RCA jack, we do hear some sound coming through, but in the pitch shifting mode, we do not actually get any repeats. On the normal mode, we do get some repeats, so that's good. So let's turn this off before it bursts into flames. So what's happening here is, again, on our input jack, we have a broken trace, and so we're going to have to fix that. And that broken trace is affecting both, well, I guess both halves of this op-amp IC13 A and B. So it's up here and down here. Up here, it's taking the input signal and boosting it so that it actually goes into the circuit, goes into our compander, goes into the bypass, etc. So that's kind of an important function. And down here, what it's doing is it's actually controlling the current that is going into, or I guess it's setting the midpoint voltage, which is controlling the current that is going into this oscillator here. And so I'm going to put a bigger version of this up on the screen, but the gist of it is that we have a negative voltage here. This is like minus 9 volts, I think, or minus 7 volts. I can't quite see on this printout here. But this is a negative voltage here, and then, or sorry, actually this is relative to 0 and 9. So this is plus 2, which is technically minus 5. And then this is plus 4.5, which is technically, no, wait. This is plus 2, which is 2.5 away from 4.5, which is our virtual ground. And then another 2.5 from that is plus 7, which is our virtual analog plus voltage. So anyways, a little bit confusing. Relatively speaking, we are getting a negative voltage across these resistors here. This is pulling current from the output of this op-amp through this capacitor, through these resistors, and then because we're putting current through this capacitor, the capacitor charges. Eventually it gets to a point where it exceeds the voltage on this divider here, and then this op-amp being used as the comparator switches on, which turns on this analog gate here, which shorts out the capacitor and resets the cycle. And there's a little bit of temporary positive feedback here to keep this output signal on long enough for this to fully reset. So because this op-amp is not working, it's being pulled to the plus 9 volt rail, I believe it is. That means that this voltage is actually positive, which means that there isn't current going through here, and so this oscillator isn't working, which means that this sawtooth wave doesn't exist, which means that it's not being clipped to a square wave in here, which means it's not going into the PLL. So that means that we do not have any pitch shifting. And so I am hoping that by repairing the power trace that's going to IC13, that everything will just magically start working, but we will see. So first thing to do is get this thing apart. So let's do that. Now, apparently someone has already desoldered these from the other side, which is not correct. So we will solder these back on properly when we put it back together. see. So this switch we don't need to remove, but we do need to remove these pots here, I believe. You can actually see by the scuffing here that someone's been in here before us, as if the desoldered ground wires weren't evidence of that enough. All right, so there's some kind of oily liquid on this board. I'm not quite sure what it was, but I expect it's like some sort of contact cleaner residue or something, deoxit, I don't know. Anyway, I want that cleaned off because I want to be able to hot glue this input jack down so it doesn't continue wobbling. This is going to be after we fix the broken trace on the back side. And we can see that this input jack is wobbling quite a bit. And we'll look at this under the microscope and show you what it's doing on the back side. But compared to this one over here, this one's pretty solid on there, so we don't have to worry about that one. But this one is mighty broken. So let me get this under the microscope and we'll have a look. All right, we are under the microscope now, and we can see this is the RCA input jack here. And if we manipulate it a little bit, you can see that, yeah, there's definitely a broken trace there, and these pads have 100% lifted. So we're gonna go ahead and solder that down. All right, got myself a pretty good angle here. I think I can scrape off the solder mask. Go ahead and clean this off. And now with a little flux and a little solder, we will go ahead and tin this. That does not look very tin. Let's try that again. That looks a little better. Should be good enough at least. Now I got a bit of 22 gauge bus wire here, and we will just lay that in there and solder it in place. And this is a little tricky working through the camera on the microscope, but we'll see how well I can do this. Yeah, I think that looks pretty good. Let's clip this off and see if it stays. Yeah, it seems to be on there. And importantly, we'll check for continuity. Now, since we don't have anything plugged in, we will see continuity across that, but I can look at that and say there's not bridging there, so I think we're good. So now, we still have a little bit of movement here, and so I'm going to hot glue the back of this, but you guys don't need to see that, so I will be back in a moment. Okay, so as we can hopefully see, the jack is now hot glued to the board, and it is mighty secure. We have our fix on the back here, and if we plug this in, we can do a little bit of diagnostics. So right here is IC10, and this is the output of our phase lock loop on pin 4, and it says right here it should be between 22 kilohertz, I believe. It's really hard to read on this printout, and something like 134 kilohertz. So unfortunately this scan that was scanned by this guy is kind of blurry, and so it's hard to read some of the stuff on here. Anyway, if we go to, let's say AC volts, so if you just have a basic multimeter and AC volts, we'll grab the ground over here where we were just fixing things. And we look right here, we can see that we have 5.2 millivolts AC, which is some AC. If we say frequency, then, let's see, 1, 2, 3, 4, we have, once that stabilizes, About 106 kilohertz. So that's exactly what we want to see. Hopefully that's enough millivolts for that. It doesn't actually specify the amplitude that should be, and I'm not sure that it's actually reading, my meter is actually reading that correctly anyways, because it is fairly high frequency, but we will assume that things are working. And the other thing we can do actually is we can check the voltages across the pitch potentiometer here, because this is actually what was screwing us up before. Remember, we had our op amp, which was feeding the center tap of our pitch potentiometer, and it was being pulled to plus 5 volts because the, plus 9 volts because the ground pin on that one was essentially disconnected by the PCB break. So we'll just pick up our ground here again. And on this one, we are looking at 2.4 volts. On the center pin, we are looking at 3.5. We're right in the center on the adjustment right now. And on this pin, we are reading 4 volts. So that is all below 4.5, which means that our oscillator should be oscillating, and we observed that it is. So that's cool. So now I'm gonna shove this all back in the box, I think. And it definitely helps if all these wires don't get caught up behind this potentiometer. All right, did I do better that time? Sort of. Let's hear. There we go. That's more like it. Wow, these screws are being a pain in the butt today. I think they might have been cross-threaded previously by the person who was in here last. That one went easy. I need to double check which order these go in. All right, I think it was yellow and orange, so we'll go with that. And if it was wrong, I apologize. I will fix them later. All right, that's the delay working. Turn the feedback all the way up. Turn it down. That seems to work. Now, pitch shifting delay. Do we have pitch shifting? Oop, no, that's the inverse delay. Pitch shifting delay. Do we have pitch shifting? We don't. Interesting. We may still have a problem here. Now, as I recall, I think I got this to work previously by attaching a keyboard control input, and that goes into this connector right here, and it overrides this oscillator here and supplies its own oscillator signal. Let me try that quickly and see if that gets us anywhere. Okay, so if I hold down a key over here. Okay, now we have pitch shifting. Sort of. Try up an octave. Okay, that is pitch shifting. So let us figure out why this is not pitch shifting on its internal oscillator still, because that should be working. And just double check here. Nothing is coming out. So let me see here. So according to the schematic, we should have a saw wave on this pin, which is 8 and 11 on IC. I see something. What IC is that one? Oh, IC 8. So 8 and 11 on IC 8. I'm going to power up my scope and get rid of this keyboard here. All right, pull things back apart here and turn this back on. So this is our pitch knob here. And on the center pin, we are, put that back into voltage mode. On the center pin, we are varying as we should between 4 volts all the way that way. In the middle, we're at 3.5, and at this side, we're at 2.4, 2.5 roughly. So that's fine. Now from the pitch knob, we go from the wiper of the pitch knob into the fine tune knob. And so, if we go over to the wiper of the fine tune, we'll put that back in the center. So we are at 3.5 here. So on the wiper of the fine tune knob, which is, I believe, the output, if I'm not mistaken, yes, the output. Wiper of the fine tune knob on the output, we are at 4.4 volts, which is not 3.5. And if we twist this way, we're still at 4.4 volts. And if we twist this way, we're still at 4.4 volts. So we can clearly see that these two pins are bridged here. So this is just working as a variable resistor. If we look at the input, we're at 4.4 volts. So this at 3.5 volts is supposed to be connected to this at 4.4 volts. And it may not surprise you that if we go into continuity mode, I'm bringing my other probe here, then if we measure from this pin to this pin, we have continuity, and we follow the trace along here to this pin, and there ain't nothing there. So what has happened here is that this trace has apparently corroded away, and I probably should have caught it earlier, but like there's some like serious gunk going on here. So I'm gonna have to bridge a wire from here to here, and then presumably that should fix it. I hope. But anyways, I'm gonna take a few pictures of this under the microscope to put on screen, which you will hopefully be looking at right now. And then I will fix it. And this is just soldering one wire, so you probably don't need to see that. Okay, now that we have this lovely blue wire here, we should be able to see that we still have our voltage here. If we go to this side, it's 4.0. If we go in the middle, it's 3.5. If we go to this side, it is 2.5. Go back to the middle at 3.5. We'll check over here. Now we have 3.5, so that's a good sign. Now let's go over to frequency, and if we hit pins 11 and, let me see, 11 and, can't see the numbers on this damn sheet. 11 and 6, I think? Anyways, let's look at 11. I can tell that's 11. So that could be 9, 10, 11. This one? No. 1, 2, 3, 4, 5, 6, 7. Ah, okay. 8, 9, 10, 11. This one. There we are. That is about 1024 hertz, or 1.2 something kilohertz. Turn it that way, 512 hertz. And if we turn it this way, it is 2082, not quite 2048. But I don't really feel like dealing with these little trim pots here. And I'm not even sure those are in the right place to adjust this. So we're just going to take this as working. So now I should be able to safely put this back in the case. So I will do that. It's going to look just like it did the last time. And I should mention, while I was waiting for the air conditioner to shut the hell up, I wrapped the chaos of these wires in a little bit of wire harness tape. That's what it's called. So hopefully this won't get caught behind the potentiometer when I insert this again. So we'll see. Okay, we are all back together here, and I am feeling pretty confident given that I put all the screws in this time. So, hooked up to my little microfreak over here, and we are just on the, what are we, at the 800 setting here. So, regular works. The reverse is gonna make weird sounds, of course. Now, pitch shift, type A. Definitely making weird sounds. Type B. Turn the feedback up. Turn the mix up. Now if we turn the feedback way up, you can actually get this to kind of self-oscillate. Now the seller of this sold it for parts or repairs and said it makes weird noises, and I couldn't agree more. So hope you guys enjoyed this video, and I will see you on the next one. Except I forgot to demonstrate the keyboard control. Go up a little bit. Go up a little bit more. Up a little bit more. So that apparently needs a very high frequency going in, so keep that in mind. So that's pretty cool. Let's try this mode. All right, now I hope you enjoyed that video, and I will see you on the next one.